Hi, this is Alex from devstories.eu. LlamaIndex, Context-Augmented LLM Applications, Episode 3 of 14. You grab the right document chunk, send it to the language model, and still get a bad answer because it was buried under 10 irrelevant chunks. Finding the text is only half the battle. Filtering, ranking, and deciding how to fetch it in the first place is where the system actually succeeds or fails. Today, we are looking at the execution phase of RAG, specifically the query pipeline, retrievers, and routers. At this stage, your data is already loaded and indexed. A user submits a query. The first component to intercept this query is often a router. A router is a decision engine. It looks at the incoming question and determines which underlying tool or index is best suited to answer it. Say a user asks a complex question about a specific historical event that also includes highly specific acronyms. A standard vector search might grasp the semantic meaning of the event, but miss the acronyms. A keyword search will nail the acronyms but miss the broader context. The router evaluates the query and decides to send it down two paths simultaneously. It routes the request to both a vector search and a keyword search. This brings us to the retrievers. A retriever is responsible for defining exactly how to fetch relevant context from an index. It does not generate answers, it only fetches data. Following our scenario, the vector retriever converts the user query into an embedding and pulls out the most mathematically similar nodes, which are just chunks of your source documents. At the same time, the keyword retriever pulls out nodes that contain exact text matches for those acronyms. Now you have two distinct piles of nodes. You cannot just blindly append all of them to your language model prompt. Context windows are limited and models get easily distracted by irrelevant data. This is where node postprocessors step in. Here's the key insight. Node postprocessors act as a gatekeeper between the retrievers and the language model. They apply transformations, filtering, or re-ranking logic to the fetched nodes. For example, a postprocessor can enforce a similarity cutoff, dropping any nodes that scored below a specific threshold. It can deduplicate nodes if the vector search and keyword search happen to pull the exact same paragraph. It can also re-rank the remaining nodes so the absolute most relevant chunk sits at the very top of the context window. Once the postprocessor has cleaned and ordered the data, the system hands it off to the response synthesizer. The synthesizer has one job. It takes the polished list of nodes and the original user query, combines them into a structured prompt, and sends them to the language model. The language model then generates the final human-readable answer based solely on that provided context. The query execution phase is strictly a pipeline. You route the query, retrieve the raw nodes, filter and rank those nodes with a postprocessor, and finally synthesize the text. If you control what the language model sees, you control the quality of the output. Thanks for spending a few minutes with me. Until next time, take it easy.